Okay, question 16. We're told that Colin took a sample of 80 football players and he records the total distance in kilometres each player ran in the first half, and then he draws a box plot for the results. Part A, we're asked to work out the interquartile range. Now, the interquartile range found by doing the upper quartile take away the lower quartile, which is this line and this line here. Now, most students are okay with that, but very common mistake is to make a mess of the scale. So, let's have a look at this scale here. If that's 5.5, this line here is 5.5, and that's 6, this line in the middle must be 5.75. So, if I know that that's 5.75 there, and we've got 1, 2, 3, 4, 5 lines, that means each of the small lines must be worth 0.05. So if that's 5.5 here, and this is 2 of these skinny lines above it, it's going to have to be 5.6. So this line here in our box and whisker is 5.6. And then working backwards, in fact, I'm going to go from here. This is 4.75, 4.8, 4.85. So 4.85. So I need to do 5.6 minus 4.85. Counting on is going to be 0.15 plus 0.6 is going to give me 0.75. Okay, second part, we're told that there are 80 players in the sample, and we want the number of players who ran more than 5.6. So 5.6 is actually the upper quartile, okay? Which means that 75% of people ran, sorry, 25%, should I say, 25% of people ran 5.6 or more. So this is this portion of the diagram is saying, right, 25% of people are here. Okay, this is the upper quartile. We've got 50% here and then another 25% here. So if there's 80 in total, and we want who ran 5.6 or more, well, we just need 25% of 80. 25% of 80 is a quarter, which is clearly 20 people. Okay, the next part. It says Colin also recorded the total distance each player ran in the second half, and then he draws another box plot, and we're asked to compare. Now this question comes up virtually every paper where we're asked to do some sort of comparison. When you see that word compare and distribution, comparing the distribution, you always talk about two things. You've got to compare an average and you've got to compare a measure of spread. Now, the average in this case that we're going to compare is the median. So there is the average distance ran by the players in the second half, and up here is the average distance ran in the first half. So if we have a look at it, we can see on average they're running more in the first half, and that makes sense, doesn't it? Because players are going to get tired. So you can say on average, in fact, I'm going to save a wee bit of time. I'm going to type it up here. On average, players ran more in the first half. On average, players ran more in the first half. How do I know? Because there is a higher median, or bigger, higher or bigger median. Okay, so that's the first mark there. Okay, on average, players ran more in the first half. How do I know? They have a bigger median. Okay, second question, the second part that I'm going to, or the second comparison I'm going to make is we're going to compare a measure of spread. Okay, the measure of spread is essentially the range of the interquartile range. Now, I like to talk about the interquartile range more because it's more accurate. Let's have a look. The interquartile range here for the second group is, that's 5 there. The upper quartile is going to be 5.1. 5.1. The lower quartile, 0.45, 0.4, 0.35. That's 4.35. The difference here is going to be 0.75, which is the exact same. So what I'm going to say is there is little to no difference in the spread of the data, i.e., or that is, the interquartile range for both diagrams is the same. So, in other words, that there's not a huge difference in the data between the first half and the second half in terms of how spread out it is. So they're both as consistent